but most people are just here to mock PHP developers. I try to defend it as much as I can. I'm not going to apologize in advance because you all know what it's like. Back in January, I started my first development job out of a foundation degree at a small company called Flax and Teal. They mainly focus on open source research and development based projects. But Belfast is pretty small, so you've probably met all of us already, and it was probably at an event involving alcohol, and I was definitely tipsy, so I apologize for that encounter. And I'd like to say at this point I know what I'm doing, but I don't. Ask me again in a year and I might have a better idea. But I do get to work on some really cool projects, and the one I'm going to talk about today is one of them. So it's a really good example of how systems can work when there are a few different components and services that are running different things. So when I started this, it was first generation code written for an R&D project a couple of years ago. So lots of dependency updates to do, so that was a fun few weeks. In super trivial terms, it's a natural disaster simulator that's written in PHP, and there are a few other things that actually make it work, kind of. So it's fine for us to read about a disaster that happens in the world or see a video and feel empathetic for the situation, but what would we actually do? It's really hard to relate a disaster to somewhere that you're familiar with because we don't have things like earthquakes or volcanoes in Northern Ireland. But like, how do we plan what would happen? What local services would we lose first, and how do we actually prepare? So this was actually originally made for school kids to help them prepare for the impact of natural disasters on human geography. So it pulls together open data, PHP and Python, a few other things, and it creates a web application that almost works. And for all of the flaws that our public sector have, there are a lot of open data sets that we can use, and there are coordinates for every streetlight in the country. So if anyone needs to know where all the streetlights are, you can get that data. There's a lot of it though. And the best part about open data is that it's free and also a huge time suck. But I haven't really been around in the development community long, but I have noticed that people tend to mock PHP developers. And I mean, I get it, but I don't really know why, because it is fun to use and I enjoy it for the meantime. And while it isn't good for processing data, it's good for seeding data, creating migrations, and managing data sets. And it does work efficiently at pulling together web pages, and it works really well with Kubernetes and Docker because of how it can scale and how it can be controlled. So Our Aging Planet is a single-page web application that communicates through various APIs. The front and back end are developed separately in different repos, and running Docker Compose while you're developing runs the entire stack from the different repositories. So the back end is developed in Laravel, which is PHP framework, and it seeds datasets from an internal CKAN instance. And CKAN is like a dataset management tool for open data. So Laravel moves this data from the CKAN instance to Python, and then Python uses it to run mathematical simulations using Phoenix and other mathematical tools. So the front end is connected to the back end, obviously, and it's made in VueJS. So it uses the data returned from the back end processes to display the markers at the coordinates contained in the data. So this gives a visual representation of local open data with coordinates and images and like descriptions of the different features, and it displays this on top of a map that's made using Leaflet.js, which is an open source mapping tool. So I was mainly working on the Laravel and VueJS components, and you can make pretty significant changes by just focusing on those and not worrying about the entire architecture, which is a huge benefit of having different services running. And having them separate makes it easier to debug. So rather than getting a million issues in one terminal, you still get a million issues, but at least you know exactly what it's for. And I kind of prefer to debug Vue rather than PHP, but it usually just means that you're putting off something that's going to break everything later on. So yeah, that does not look good, but there are some data sets that need to be visualized on top of a map, and it takes up a lot of memory, and it sometimes crashes everything. All the time crashes everything. So there are data sets for I think all the gullies in Northern Ireland, if anyone needs those as well, they do exist. But the one for Belfast specifically has over 26,000 different entries in it. So if you try to put that on a map, it doesn't go well, and this is just a small part of what it looks like, and it looks like a complete disaster. And if you try to run it, everything will freeze and your computer will shut down. So it took a few hours of developing at the beginning to figure out how to not let this happen. I'm not really sure, but yeah. So how do you get a ton of data like that to actually display on a map with icons that the user can recognize that represent a specific thing? So at the minute, this map is trying to load 26,328 drains and over 1,200 buildings, as well as some schools and bus stops and train stations. So we have to end up clustering the data, and this way the map just needs to load a few different points rather than everything at once. So when we chunk the data, it's used to identify landmarkers in the simulation. So the location is user-defined, and any location in Northern Ireland, it can populate the data as long as the data is actually there. You can select different data sets to show. And the feature ID is found, or feature ID that represents each feature set is found when the simulation runs, and it fills in the feature arc, which is basically the simulation running and the health and status of each feature set that's affected during the weather phenomenon that we're creating. So separate APIs are used here because some of the feature data isn't actually needed. So feature arcs actually represents large amounts of 3D data. And this is just the structural health of the features like buildings or schools, other things in the simulation. So the structural health is, when it's sent from the backend, it's health over latitude and longitude and time. So places get damaged over time depending on the weather phenomenon, so this needs to actually be displayed in the data. So separate APIs are used. So the icon location, images, description, they're not going to change depending on what stage of the simulation you're at. So you don't need to send that data every time. So the data can be recombined in the browser, and because it only needs to know the updated health values during the simulation, it puts less strain on the back end from all the data it has to return. So this is what it looks like when the simulation runs. It shows an area of effect on the map. So this is where the Python data models are actually used. So the simulation data is sent from Python using OpenFast, which was in the diagram that I showed earlier on. So the simulation is actually made using Phoenix, which is a library running in functions used in OpenFast. There's one class of Phoenix or other numerical-based functions for each type of simulation that's running. So Phoenix is an open source tool for mathematical simulations that can be made in Python. So Laravel gets the data from the CKAN instance using the seeders, and then it gives the data to Python to get processed, because PHP can't actually process the data very well. So this means the simulation can do things like show lava flow down a mountain or water levels in a hurricane storm surge. So this bit's actually really cool. The area of effect on the map is created using a JavaScript library, and it uses the convex contouring algorithm. So it finds the outer parts of the simulation, and it just finds the feature markers that have affected health, and it figures out where the simulation's running, and it draws different lines around the data, and it renders them to create a 3D model on top of the map to represent the phenomenon that's happening. So this helps the user actually visualize the extent of the data, or extent of the damage, sorry. So the actual simulations are what's running in OpenFast. So OpenFast is serverless functions, and it's using a series of Docker containers that are communicating with Kubernetes, and it tells it to scale up or down depending on the processes that are actually running. So the simulations in these processes, they're essentially smallish data, big computation Python functions, so they need to run for a long time. However, as long-running serverless functions were pretty new when this started to be developed, this is a very new addition, but we're able to fire up any number of long-running simulations for each type of natural disaster that we're able to simulate. And in the future, we're hoping to simulate a velociraptor attack. So if anyone knows where to get open data for dinosaurs, that would be really cool. And when the simulation data is returned, there's actually visual gaps between the points in time. So we use linear interpolation to fill in the gaps and make the simulation run smoother. So this is the equation for it, which I'm not going to explain. You can Google it later if you want. So it adds a percentage of the difference between 0.0 and 1, and it just depends how far in the simulation it is. And then it adds the difference in time to the previous time's value. Does that make sense? Okay, cool. You can ask questions after if I'm not explaining very well. So the code that we actually use it in is here, and it's just taking the time values and the health values, and it's just putting it into the equation. For each point of a simulation return from Python, it finds the 2 points in time, and it figures out where in the simulation it actually is, and it just runs the equation. So there is a lot going on here, and because there's so many different scientific processes running, it can get really, really messy. So this project shows how useful container-based web applications can be, especially when there's so many different services doing so many different things. And there's a heavy emphasis on data science here, so that's why it's really good to implement containers. And also serverless analytics functions can be easily and scalably integrated in a complex architecture like this one. But working with free resources like open source software and open data has really strong benefits. And I definitely haven't been brainwashed by anyone in particular, but I really love working with open source. And I'm always going to advocate for transparency, especially within government published open data, like the things that we use in this project. And because I get to work on open source, it encourages me to write good code most of the time, despite the debugging messages in my PRs. So with this application, there's a lot of freedom with what data sets can be used. Basically, if it has coordinates, we can find a way to bluff it into the project that makes business sense. And because PHP is actually seeding the data from CKAN, which already has all the management functionality that we need, it means that the servers that we're using don't need to store a ton of data, so it's not as heavy as you'd expect for a simulation application. And PHP isn't that bad, although if we tried to do all this in just PHP, it would be a complete natural disaster, which is why we've used containers like this. That's it. Yeah, I know there's a lot of different processes there, and people probably have some questions, like when we're going to rewrite it in Rust. We definitely are at some point.
It's a criticism here.
So yeah, if there's any questions, yeah.
What specific problems do you have in PHP processing data?
PHP is kind of slow. Python's good for processing data.
Okay.
So it was just.
Size, like the size and usage, or the amount of operations you're trying to do on the data, or something?
Yeah. Yeah, just all of that. It was developed long before I arrived here, but from what I gather, it was just because of the open source tools available in Python, and PHP is not known for its ability to process any data. Does that answer the question?
One last one, what version of PHP?
It's Laravel, the most recent version of Laravel.
Okay.
Because I remember specifically updating it, and I remember specifically how traumatized I was.
Fair.
I've never actually had the opportunity to work with open data before, and it's something I'd be interested in getting started with.
Yeah.
How do you find open data in the first place? What's the best place to get that kind of information?
So there's Open Data NI or data.gov.uk. Northern Ireland is really good for publishing open data. This guy knows what I'm talking about, apparently. There's loads of data sets. All the city councils constantly publish open data. So yeah, it depends what you're looking for, but Open Data NI is definitely where to go. Does anyone have more questions?
If you could change one thing about the current architecture, what would you change?
I don't know. I'm worried about you're going to tell my boss. I don't know. The good thing about the architecture is that because I'm really new to this, I don't entirely understand what is going on. So the bits I do understand, I get to focus on without looking at the whole thing. That doesn't answer your question. I'm not going to answer your question. I don't want to change anything. It's perfect. Rust and WebAssembly, though. Are there any questions unrelated to PHP? Or? Okay, well, yes?
Yeah, just in terms of the nature of the app and the open data, is it difficult keeping it up to date? Because it's like if there's changes in where like if they move a street light.
So the way CKAN works, we can like program it to update when data sets are changed. Currently it doesn't, but it will. I think that answers your question. Are there any more questions, or is it getting really awkward now? You have a question? At the back? No? Yeah?
So I guess in terms of the analysis, what is it that actually serverless functions, is there a benefit to using those for doing analysis? Sorry?
The amount of time simulations need to run.
Yeah. So I know for lambdas it's limited to 5 minutes.
Yeah.
Thank you.
Okay. You can leave now if you want. Yeah, thank you for listening.